Hello, this is Gao Yuan from the Master of Science in Business Analytics in Nanyang Technological University. Today in this demo, I want to show how to do the data analytics using regression, decision tree, and neural network in Python and R briefly. Firstly, I'll do the data cleaning. After I download the diabetes file from Dropbox and read it, we can have a look at how the data frame is. So I use the method head and also check the type of each column, as you can see here. In case of modifying the raw data wrongly, I make a copy of the original data. Also, I calculate the mean age before removing non-numeric fields. It's just for comparison later. Okay, now let's start cleaning the data. I take two columns, age and blood pressure, as an example. In terms of the non-numeric field, I firstly scan the arrows in the age column and find there are two arrows, so I replace them. Consequently, the mean age after removing non-numeric fields is, as you can see here, 33.27, which is different from the 33.31 above. Also, I scan the blood pressure column and find one arrow here. Similarly, I replace it. And the mean after removing the non-numeric field is here, as you can see, 71.31. Okay, in terms of the outliers, we need to sort the counts of each age before cleaning it. Then I found the 4, 9, and also 135 are outliers. So I remove these three numbers and have a check. Okay, it's down here. Now the new mean of age is 33.25. Good. As for the blood pressure column, let's do the same thing. Sort first, and I take values below 20 or above 130 as outliers. Then I calculate the mean without the outliers, which is 72.56, let's say. So what's next is modifying the values of outliers in blood pressure. Oh, sorry. In the end, we can have a check. The mean should be the same here. It's also 72.56. And we shouldn't see the outliers here. Okay, perfect. So this is the first part. Next, I'll build three kinds of models using regression, decision tree, and neural network respectively. As for regression part, after importing the modules we need, we firstly do the pre-processing, including changing Y to categorical and splitting the train set. Okay, I also standardized it. So as you can see here, I use the getDummies function in Python to change Y to categorical, which is different in R Studio. And I use the train test split function to split the train test set. Okay, so here comes a logistic model. And we need to have a look at its accuracy. For logistic model, we usually use the confusion matrix to show the whole result in order to make it more visualized. We'd better plot the confusion matrix. So as you can see here, the accuracy is 71.43%. And I use the plot confusion matrix function to plot it. Okay, it's done. So it's more vivid. We'll remember that we got the 71.43% accuracy above, and there are at least two simple ways to improve the model. One is selecting statistically significant features. So I use the API here. Firstly, import it. And as you can see here, according to the p-value, we can pick x1, x2, x6, x7, and also Y column to build another new model. So let's have a try. As you can see here, I picked these 5 columns. Oh yes, the accuracy increases to 73.38%. Another way to improve the model is use the standard scaler to standardize the data. As you can see here, I changed it so the others are all the same. Oh yes, the accuracy also increases to the same, which is 73.38%. Okay, so that's a part for regression. Here comes the decision tree. After importing the modules we need and reprocessing the data, we firstly plant the tree. Well, please note that I didn't set the max leaf node parameter here, and the accuracy at the first time is 61.69%. It's relatively low. There may be an overfitting problem, so I set the max leaf node parameter here to 10. Let's have a try again. Consequently, yes, the accuracy increases to the 17.78%. It's good. Usually, in order to interpret the data better in decision tree, there's no need to standardize the data. In this model, if I standardize them, the result would be the same. Yes, still this number. Okay, now we can have a look at how the decision tree model is. In detail, it has 19 nodes, as you can see here, and we can also get the frequently used children left parameter to describe the tree. At the same time, we can plot it. Okay, it's done. We also need to get the model, got the ideal model. So I need to prove it. As you can see, the larger alpha, the more we prune, the more impurity is. So among many different models, we want to find the best one according to the accuracy of test set rather than train set. So I plot the scores to have a vivid look. Here it is. We can find that the highest validation accuracy is about 74.68%. Okay, the last part is about neural network. We need to use the keyword model. So firstly, importing. When we build the model, we could set different activation parameter and different values here. As you can see, we could also add the dropout layer to avoid the overfitting problem. Namely, 20% of the nodes won't be put into consideration in order to avoid overfitting. Then I repeat the same pre-processing, making Y to categorical and standardizing the data. Well then, when I set the input dimension 8 here as the number of independent variables and run the model for the first time, we could get the accuracy at about 70%, 71%. Okay, so that's all for data analytics in Python. In the following several minutes, I will show how I use regression, decision tree, and neural network in R. In RStudio, I directly use cleaned data called diabetes cleaned. So let's try step by step. First of all, I use vector function to change Y to categorical here instead of getDummies in Python. Then similarly, we can have a quick look at the data table. All the independent variables are continuous. Then I use cartools to split the tree test set. In order to reproduce to verified results, I set seed, which I will do again when reporting other libraries later. After splitting, let's have a check. As you can see, the distribution of Y is similar in training set and test set. Okay, now I'm going to do the logistic regression first, using the GLM function. In model 1, I select all the X variables. Then I test with the test set, using the mean of Y as the threshold. If the probability is over threshold, then predict Y as 1, else I predict Y as 0. The last step is creating a confusion matrix with actuals on rows and predictions on columns, and also calculating the accuracy, which is at 77.9%, as you can see here. Well, remember, as what I did in Python just now, I try to select features that is statistically significant according to the p-value. So I did the same thing here in R. According to the p-value above, I select 4 X variables to build the model 2. After doing the same processing and calculating its accuracy, I find the accuracy decreases to 77.3%. It implies that we need more variables to predict Y in this model here. We also need to combine our practical experience in the reality. Okay, the second part is about using decision tree to build models. The library we need is rpart and also rpartplot. So let's import them and also set seed. Well, when I grow the tree, the default complexity parameter, which is called CP, is 0.01. But I set it to 0 to guarantee there's no pruning. As a result, the model tree, as you can see here, the tree is very, very big. So we can get more details when we print model tree. And we can also plot the CP value. So as you can see, the plot goes up in the middle, which is not ideal. we definitely need to prove the tree to avoid overfitting problem according to the CP value. So I choose the minimum CP value to build the model for. Well, let's try again. Now, okay, the CP plot looks nice. We can also plot the tree here. Okay. Well, according to the variable importance in the model 4, we can easily find that the plasma glucose concentration, and BMI, as well as age, are higher in importance than other features. Lastly, I need to test this model with test set and produce the confusion matrix. Okay, the accuracy is about 72.1%, which is less than the regression model above. If you want to see the details of model 4, you can use the summary function, as you can see here. Okay, the last part is about the neural network. The frequently used libraries in R is neural nets and also nets in the following. So for Model 5, I will first use neural net. Well, to reduce the computational requirement, I firstly normalize the data between 0 and 1. Okay, then build the model. We can plot it. Okay. Also, next we can get more details in the result matrix. And also weights. But I think we can actually see the weights more directly in the plot here, the number above each line. Well, as for the generalized weights, it's easier to view them as plots instead. So let's draw them. There are 8 in total. Okay. Through these generalized weight plots, we can understand to what extent the variable influences y. Lastly, because the neural net doesn't have the predict function, I use the if-else to make a prediction. Based on it, I produce a confusion matrix and also calculate the accuracy, which is here 79.6%. As I mentioned just now, another library we can use is a net. So let me show you. It cannot show the network diagram, but it has a prediction function when compared with the neural net library. So it can easily produce the confusion matrix. Okay, as you can see here, and also accuracy is at 69.8%. Okay, so I show how regression, decision tree, and neural network work in both Python and R language very briefly. That's all for my today's demo. Thank you for your watching. Thank you.